Let's let me tweet that we're live. Okay, can you see my video, I guess, everyone, ASU people? Hello? Awesome. Okay. Why is audio so quiet? Can someone say something? Perfect. Okay. I'm just gonna hop on to the Zoom link on a different device to turn off the doorbell, and then we'll get started. Where is my Zoom? Meeting settings, turn off the doorbell. Doorbell is off. Okay, awesome. So is my audio going at like 2 frames per second, or my video going 2 frames per second on Zoom? Why? This makes no sense. How about the video on Twitch? Let me. Okay, so some sort of a weird Zoom issue. Bueno. Okay. Cool. All right. Awesome. And now I'm in the Zoom chat, in the Twitch chat. We'll give a couple minutes for, maybe one more minute for people to filter in, and then we'll get started. All right. So let's let's fire this up. All right. So we're gonna start real quick with a state of the course. The state of the course is don't panic. If you're panicking, stop panicking. We're gonna start with a very important thing, meme highlight. So these are some, well, these are literally all the memes I saw about the course, but I didn't see all the memes, but the ones I saw I liked, so good job. Especially like von Neumann over here. And yeah, blue shirt Jan unfortunately couldn't make it today to stop me from launching this homework assignment, so that's what you get. All right. Question on Twitch: where to post memes? This is a good point. I'm going to tweet the Discord link for non-ASU students. So we have one for ASU students, one for non-ASU students. It's important to use the right one, otherwise the Discord will get screwed up and we will probably have to kill it. So we are going to not paste the wrong one. And that's where we'll do the collaboration hour today. On college collaboration. Okay, so I've now tweeted the Discord for the non-class. Just Same Discord, different setup. So there we go. All right, now let's roll. There's also a memes channel there for everybody, and then we'll go from there. All right, so where are we in the course? We finished up the intro, fundamentals, and the set UID assignment. Hopefully everyone enjoyed that. The assignment is designed not just to show you the security problems that can arise if you give too much access to different programs, and those security problems are very real, as you've seen. It's also to get you familiar with Linux on the command line. Hopefully everyone has a better understanding of the command line and Linux than they did when they started this assignment. If not, we can launch some other crazy stuff for you. All right. Let's see. Why are there Discord links flying everywhere? All right, cool. So, very cool. Today we're moving on to shell coding. We're going to, hopefully you have already all watched the shell coding videos. As a reminder, the course is designed so that here in this lecture we talk about videos. So 2 hours before this, Connor streamed all of the shell coding videos that are also on YouTube. I'm going to just go to youtube.com so that you can see that they are there. Let me first find it because I am a bit of a noob. Actually, here, let me. All right. This is pwn.college. You go to Shellcode, here are the videos. All right. I'm now assuming that everyone watching the stream has watched those videos. If you haven't watched the videos, I mean, you can tough it out on the stream, but if you want to go and catch up on those videos and then watch the stream is an extended Q&A culminating in 1 or 1.5 hours of collaboration session on the next assignment. Right now, as we speak, Connor is hard at work posting the next assignment, so the module 2 challenges, the shellcode challenges, should be up shortly. Cool. All right. Sometime while we babble. Let's move on real quick. Slight change in the course kind of times. I added this pre-class lecture stream at 2:30, and then at 4:30 we do what we're doing right now, which is watch me use try to use Twitch. On Twitch, we have someone reporting that what they learned, actually someone in the top 20 of pwn.college right now, judging by the name, maybe, that they learned that there are millions and millions of hex editors and viewers. And we're going to run through some common strategies. I forgot to make slides for those, but we'll babble through. All right. So, moving on. Right now, with pwn.college open to the world, you can see how ASU performs against the world. Of course, there's, the ASU students have to do this in order to pass this class and graduate. People worldwide don't necessarily have to do it. But right now, ASU is giving a very strong showing. All of these pitchforks, that's, the ASU mascot's weapon of choice, I guess. Yeah, so right now in the top 20, we have 2 people from outside ASU. Hopefully, we'll see more competition there. The question is, when we start getting to harder and harder and harder concepts, can ASU stay in the lead? That'll be interesting to see. All right. Let's talk about Module 1 results. So 157 out of the 209 students that started this class, ASU-wise, made it through Module 1. Congratulations. Great job. Actually, this is probably the best performance on Module 1 that I've seen on this course. This is a great layout of all ASU.edu email addresses registered in pwn.college. We have not yet developed the functionality to pull out the ones that are actually in the course, but that'll happen today or tomorrow. We were kind of developing in production live, just in time development. But I think it's safe to say that the people that did really well probably aren't the people that dropped. And so as a whole, if you just add up, be super optimistic and add up the top 157 ASU email addresses, the class is in very good shape. So many people have a perfect score right now. Of course, modules are going to get harder, concepts are going to get harder, but we'll adapt through that. I want to get a quick feel for how people are finding, whether on Twitch or on what's it called, Zoom or whatever. How are you finding? Comment on Zoom. Shellcoding is about to hit us like a truck. That's right. All right. How are you finding the format of the course? So my hope, and actually one reason I think people are doing well, is that you can go back and watch, all of the very specific concepts and so forth. All right. Someone on Zoom saying the format is great. Love the gamified version of it. All right. Let's see. Cool. If you have any feedback, someone's really excited that we had 100 challenges. We'll try to have more for you. Exactly. Cool. One thing that I observed, I'm going to run this by kind of the live channel. I observed that it's a pain in the ass to record these 40-minute long, hour-long lectures, the videos for the modules. I am planning on splitting them up quite a lot more. Something like that initial shellcoding one will be just like, I don't know, 5 or 6 different 10-minute videos instead of one, 40 to 50-minute one. That might be one route forward. Okay, so the concern I'm seeing from the Zoom chat is that 100 is going to be a lot of challenges if the challenges get harder and harder and harder. It's so the challenges will get harder and harder and harder. I don't think we're going to hit 100 again. There are some challenges where we'll have some modules where we'll probably have 50, 60, but I don't think more than that. 100, because this is by far going to be the easiest homework. It was if you assign less than 100 of these problems, it becomes very, very easy, right? I think everyone probably very quickly reached 30 or 40, and then they had to start being creative. People are requesting 99 on Zoom. All right, question on Twitch. How long did the first assignment take you? I think, Connor, are you on Zoom right now? Yeah, Connor's on Zoom. What do you think? Let's say how long would that assignment take you? So the question from Connor, which is a little bit of looking ahead at discussing how to do this assignment, is the question, how long is it going to take Connor's script, or how long would it take Connor? Right? So when Connor and I wrote this assignment the evening before the first day of class in 2018, I think we sat down and we got 40 points in like 10, 15 minutes, and probably would have solved it in an hour or two. My personal best with a very simple script is, I don't remember, 200 something. don't remember. Connor, how do you remember how much like a simple script gets? Yeah. So with this assignment, scripting is very powerful, right? Let me show you something here. Okay. How can I show it? I can go to. All right. Here's one route to getting flags. Let's say connect up. I think I had this in practice mode. I did not. Let's go to pwn.college and set it up in practice mode. So we're gonna just start up bin cat in practice mode, just so I can use sudo instead of having to. Someone on Zoom says, "Dang, I only got 5." It's a hard challenge. Okay, so user bin is full of. Oops, you can't see that at all. Okay, user bin is full of challenges. Right here they are. Here's what we can do. ls user bin. This gives you. Let's do ls -d. Everything here. Full path. Use parallel to execute the binary /flag. And actually, let's see what the flag is. So this obviously will just give one flag. But if you do this and script pipe through pwn.college, or sorry, grep pwn.college. Actually, let's grep it outside of. God. What is going on here? So one interesting thing, actually, let's do grep-a. One interesting thing that we can observe right away is there's an enormous amount of crashes of these programs. Look, I run this program. A student of mine came to me about this, like, hey, I'm finding, finding a bunch of programs that just straight up crash. So obviously, in the real world, or in the real challenge, you don't have sudo. This is in the practice challenge. In the way that you would do this is pull down the Docker container that Connor announced, or install all of these packages on your own machine or whatever, which is probably a crazy thing to do, and then run this offline, figure out the solutions, and then apply them online, right? Instead, here we're just going to do sudo. Instead of running sudo a million times, we'll just sudo parallel. All right. And we hit enter. Hold on, let's do grep-a. A lot of core dumps. Parallel hitting limits. Connor, what are our limits here? We can have 100 processes. Let's do 4 at a time, because n proc is going to tell us I have 32 cores. That's what's going on. Okay. So let's do 4 at a time, and let's do a random sort. BR. Hold on, let me remember how to do a timeout with parallel. Dash dash timeout. Nice and easy. Okay. Should have actually run this to practice. Okay, so right away we have one flag pop out, right? So this was some program that just by running it with /flag prints you the flag. So let's keep going. I just realized I'll probably end up deleting the flag at some point. That won't be good. Let me SSH in and make sure the flag hasn't. I haven't deleted my own flag yet. Okay, you're wondering what's going on? Why isn't this working? I'll show you as soon as I find this to get my terminal back. Give it back. Okay, guys, this container is pretty hosed. Okay, there we go. All right, let me show you what happened with the flag. So, all of this has happened with the flag. So the flag was converted into a million different formats and then eventually replaced with a directory that has a bunch of crap in it. All right, so obviously you need to be careful about destroying. Probably a better way to go would have been what I'm about to do, but we're doing this live. So for example, let's look at what flag.o is. Some interesting stuff. Let's grab pwn.college. All right, let me restart the container. That is hilarious. Okay, connect back in. All right. What happened here? Why is it suddenly yellow and red? Is my flag back? My flag is back. Connor, can you speculate on why my @ is suddenly yellow or green? I'm colorblind. Okay, anyways, we'll deal with it later. Okay. Connor, is the server under heavy load because, or is my internet bad? Okay. Anyways, let me redo that parallel. Find where it is. There it is. All right. Instead of doing this, we're gonna make the flag readable by everybody. So now we can do this without root access. What is going on? Maybe probably everyone is running these scripts at the same time. Okay, let's not worry about this. Let's run. Okay, so now the flag is just readable in practice mode, of course. Let's just do this without sudo. So now there's no hope of the flag getting destroyed out from under us. Here's 1. There's 2. and my console got screwed up. Okay, we're back. Hold on. Let me reset. What's running as my user? Nothing. Okay, good. Okay, I've wrecked this directory pretty good. That's fine. One sec. Let's do this. New plan. Grab pwn.college. temp/flags. Okay. So now parallel is gonna lock to temp flags. Oh, I must have run something that makes my bash prompt very temp flags. What's going on? Why isn't it finding it? Oh, it's randomly choosing things. No, it is hanging. Oops. All right, we're very quickly approaching point where return on investment is decreasing. Let's do this. Okay, so you see, if you run it, we immediately start getting things out. And if we actually do the grep inside, just don't understand why it is so hard to kill it. Connor, can you look at the load on the server? Is it just destroyed? Okay, let's do this. We'll do the grep here. And then we will do -v for parallel. Just to see that it's making barriers. All right. So we're running everything with /flag, and somewhere in here, a flag might have shown up. Oh, no. Interesting. My internet connection is not very stable right now, but Twitch is fine. Okay, and a lot of these are probably, oh, here's another one, LWP request. Here's one from strings. And so already in, I don't know, the 30 minutes that I've been fumbling around with the command line, we have like 5 flags, right? There are 9,000 programs here. For some reason, this locked up and is not timing itself out properly. But with an intelligent script, possibly a more intelligent script than I am writing here, we can get quite a lot of flags just from. Oh, where did my timeout go? Let's do double timeout. Timeout. 1 second, and then here, timeout 2 seconds. Oh, there was another one that just scrolled by. Here's my terminal's fucked up. Gosh darn it. So you can see tons and tons, and my terminal is really, really broken because of whatever just happened. All right. Tons of flags. And then probably there are tons of flags in here. Oh, low. Yep. 2 more. Oh, 1 more flag that. Oh no, that's just the symlink. Could be some flags in this automatically created insanity. All right. That's the scripting route. And notice all I did was command/flag. There's a lot of things. Command-F/flag. Command -- file or something, right? haven't even started down the road of putting in the commands to execute or libraries. This module was the base of a CTF challenge at DEF CON CTF. Actually, 20.scoreboard, no, dot overflow.io. Nope. So at this last DEF CON CTF qualifiers, if we look at this challenge, this was based on this homework assignment, but to see who could get the most challenges. Initially, when the game started, teams would have to submit 9,000 solutions. So those of you comparing or complaining about 100, think about 9,000 in 48 hours. And by the end, that threshold degraded down until it was solved at, if I remember correctly, about 800, 900 solves. By one team that had 800, 900. Altogether, all of the teams at DEF CON CTF found 1,870 different programs with which they could read the flag. Cool? Cool. Okay, some questions on Zoom. How do you know which program leaked the flag? Let's scroll up. My terminal got screwed up, so I'm going to have to do this. And let's just log it to /flags. All right. So if you see what is running here, it ran HTML to text, and that leaked the flag. It's all the same flag because right now this is a practice session of bin cat, right? So you do this in the practice session of bin cat, and then you can figure out, you can launch up a real session of HTML to text, run this command, and it'll give you the flag. Pretty cool, huh? All right. So that is kind of an easy mode way of getting a ton of flags just in those, whatever, 10, 20 seconds again that I was running this. I got 6, 7, 8, 9, 10 programs that 11, 12 programs that could just be gotten with /flag. Cool. All right. Let's see. Catching up on questions. Oh, shit. Can't see on Twitch. God damn it. All right. Sorry, guys. I ran it again. The question was, how do you see what command got the flag? So you can see it from the output from parallel. If you do parallel-v, it'll print the command before printing the output. And you can see which command got the flag. So vcat can get a flag. Inline detox can get a flag. CPP7 can get the flag. And just I ran this for 10 seconds and it spewed out a lot of flags. Of course, if you know this coming in and are good enough at scripting coming in to the assignment, then it's not as fun. Now you can script this and see how many flags can you get. But if you came in with it, yeah, you could ace this assignment, but it won't help you learn how to misuse these things. All right, questions on Zoom. Yeah, so many were pretty simple, even if not just trivial, like passing things as a config. So in the same way, you can run these scripts with like -- config /flag and so forth. If you have let's say you wanted to figure out how to leak the flag with ls, I don't think that's possible, but who knows? You can do -- help. You could actually write a script to parse all of these options and automatically run command -- option /flag, right? It's pretty exciting stuff. All right. Yeah, so someone on Twitch said they didn't realize the practice side has more permissions. That's the whole point of the practice side. It gives you root access so that you can debug. Awesome. Okay. Cool. Yeah, so someone on Twitch said they tried to create a setuid cat binary in their home directory. This does not work. Can I check mount? Yeah, so if you look at mount, and you look at where /home is, home CTF has a mount option called no setuid. This specifically means that you can create a cat with setuid and then launch with other programs and try to read the flag, but it will not work. Cool. Okay. Any other questions? What is the name of the Docker image? Is a question. Connor, what is the name? It's pwn.college baby suid. You can pull down this Docker image. Pwn. Oh, R. Oops. You can pull down this Docker container. It's like 16 gigabytes, and play around with it. Oh, how did you get to the practice? Okay, again, you put in that same the correct path, and then you hit get practice challenge, and it'll launch the challenge with sudo access. Cool. Ah, fudge, cannot see. I need to get better at this. All right. Again, the container is right here. pwn.college /babysuit, and we'll be pushing like other containers that'll help with working on stuff. Like this is the base of the challenges for um, for this for the future challenges of the course. Someone asked on Twitch, do you have any recommendations for learning resources on Linux scripting? It's been so long since I learned Linux scripting that it's tricky to say. I haven't followed like tutorials recently. Anyone on Zoom have recent experience or on Twitch? Yeah, so someone on Zoom said do all the over the wire challenges, but script each one. So over the wire, let's pull up Wargame Nexus. There's a list of different war games. You can start with Over the Wire Bandit. It's a big war game for learning to use Linux and so forth. Yeah. Cool. Let's move on. All right. Some of the solutions I wanted to showcase specifically. Let's look at, was it keygen? Yeah, actually I have to go remind myself which one it was. I posted it as a hint for people. Okay. So there's a couple of tools that will take a module, a plugin, right? One of the, let's say UMView. If you look at the help of UMView, you have this, a load plugin named file. It must be a shared object, right? This means that you can have this program with a command line option load any shared object you want, right? And you remember, let me get out of that. If we do cat flag.c, so here's a cat flag from a main. In the same way, oh, Connor, you showed this on stream, right? On your office hours. Okay, so let me search for the constructor. Yeah, there we go. So I'd shown this in one of my fundamentals lectures, how to create an LD or a library where the moment it's loaded, it will run code, even with no actual functions in that library being invoked by the code using it. It's just a constructor that invokes code right away to initialize state. Well, you can do this, right? You can get the flag very easily on module load by creating something like this. Let's compile it. Cat flag.so, cat flag.c. We SCP it. Okay, let's SSH back in. And actually, let's do this. Let's do this on a real instance, not a practice instance, just to drive home the point. Okay, SSH in. Okay, so we have cat flag.so. Okay, we can't cat/flag, permission denied. We do view, and we do a I forgot now, -p for the preload. We do our cat flag. Oh, /cat flag. Oh, invalid argument. Hold on. Commands. There's dash. Well, there's a help probably won't do it. I don't know. Dash. -v is, yeah, how about that? Module preload. Let's take out this. Module preload invalid argument. I wonder if it needs something. So here's a good example of, let's figure out what's going on. We'll do the practice challenge. We'll do it in practice mode rather. SSH in. We will, of all the things installed on this, ltrace isn't installed on it. All right. We'll just install the random stuff on my machine and ltrace it. And see what it is trying to do with my module. This might be a little more complex than what we signed up for. Gosh darn it. Why not? Let's just give it root access. Can we have? No, trace is not as smart as strace here. Hold on. DL. Maybe this is what's going on. We don't have a pure start, possibly. Let's just. Get. Okay. No, it's something. I mean, let's just put that in just for fun. Still invalid argument. All right, we went off script and it screwed us over as usual. But that's fine. That wasn't looking it up from there. Why isn't it even loading my cat flag guy? All right. Come on. What's another? Let's grab another. VDR is another one. Okay, VDR. I'm just gonna. Okay, so what was VDR saying? Wow. Can't access video directory. Is there something that's like video directory? Oh, search for plugins in this directory. And for sure there's a plugin. Aha, plugin. Okay. There we go. Video directory. So we want the plugin directory and the video directory to be our home directory. Was that capital V or lowercase v? Lowercase v, right? Yeah. Video directory, and we want to load a plugin. How did we load the plugin? -p. So let's make cat flag.so into what it wants it to be. We need a VDR plugin creator in cat flag.so. All right. Yeah, there's a request on Twitch to move on to this week's. We will do that in 1 second. I just want to solve this. I just create. Oh, oops. Yeah. To make it the right thing. Lol. Where's my flag? All right, we're gonna move on. There's some thing I still have to debug. I will post an update when I figure out what the hell is going on, and we will try not to go off script. But as you know, I'm very prone to going off script. All right. let's F's in the chat. Let's move on to shell coding. Any other questions on this assignment? All right. Everyone wants us to release the challenges. Let's talk about the challenges for the shellcode. Connor, are they up? Okay. Level 1 is about to go up. So you'll go to pwn.college as normal. The challenges are going to show up under Baby Suet as Baby Shell. And you will learn to shellcode. So hopefully you watched all of the lectures. Anyone have questions about the lectures? There's one question that I have queued up to go into detail. Any others? How many levels for homework? I think we have 11 levels with a teaching variant and a testing variant for each challenge. When Connor brings up level 1, I'll show you what that means. And that's, no, sorry. I think we have 13 levels. Where is the Discord link? The Discord link is on Twitter. Here, hold on. There's some strange baby noises. I'm going to go check them out. I will be right back while Connor gets this running. Be right back. All right, we're back. Sorry about that. The baby was there is a baby yawn. Having awesome, yeah, baby yawn. What if the baby did teach Baby Sued? Yeah, exactly. All right, cool. Connor, how are you doing on level 1? Yeah, awesome. Okay. So, Baby Shell is now up. If you grab Teaching 1 and we hit play, let's play on a practice challenge. SSH in. Did it work? It didn't say it worked. Is this, okay, no, now it says I can connect. Yeah, I think we might be getting hit by a fairly heavy load. Connor, I think it might be time to increase the size of this instance. Do you got it? All right, I'm gonna show it on my machine. So luckily I was able to download it. All right, you need Capstone to run the teaching challenge, and I will show you why. Lib Capstone 3. And it's nice and simple. So literally watching the lecture, you should be able to get like levels 1 through 3 or 4 probably, because they're all small variants on just write a shellcode. Let's launch Baby Shell. The challenge, the teaching challenges will help guide you through their solution. So this teaching challenge, for example, maps your shellcode somewhere into memory. Some random location. You can see it in this one. Actually, maybe you can see it in the testing one too. But it'll walk you through what it is doing and talk about everything. Then the big thing that the teaching challenges will do is if you put in a bunch of shellcode, right? Then you end up with it'll disassemble your shellcode and show you what it is about to execute, right? So it'll show you this, it'll execute it, and then this shellcode just pushes RAX on the stack a bunch of times and crashes. If we do this, yeah, pop RCX and crash. Cool. Yeah, Connor, more reports on Twitch of flags not being submittable. Oh, perfect. Someone asked me, what did I just install? I installed libcapstone 3. Are teaching 1 and testing 1 parts of this assignment? Yes. Baby Shell will have something like 26 total instances across 13 levels. And you will have to solve it in teaching mode and then solve it again without the hints. All right, so someone already solved level 1. Awesome. Who solved it? Blue shirt Jan. Amazing. Good job. All right, let's SH in. One other thing, you might say, you might notice when you download it, the challenge, it gave you a binary file. You don't know how to look at binary files yet. You know what they are from the fundamentals lectures. You know they're full of assembly, but you don't know how to reverse engineer them. Well, we know that, and as soon as this gets in, awesome. If you go to /, there should be source code here. Connor, okay, we're gonna reboot it real quick, and then sources will start showing up, and then I'll show you the source code of a typical challenge. Will we ever need to work outside of the web instance? It's a question on Twitch. It's going to get more and more of a pain in the butt to work completely inside the pwn.college instance. You're going to want to set up Linux on your machine, whether in a virtual machine or a Docker or whatever. Set up Linux in an environment and go from there. Cool. Someone on Twitch says they actually do know how to reverse engineer binaries thanks to the pwn devils. Oh, one thing we forgot to talk about is last weekend CTF report. So let's, while Connor gets things rebooted, let's go here. We go to ctftime.org. Amazing. All right. Last weekend, there were a number of CTFs. There was specifically, I suggested to my students, the ASU students in this course, that can participate in CTFs for extra credit, that they can participate in either F-word CTF or in got CTF. And 29 students did. I'm very proud of you. This is an awesome result. I got 29 individual write-ups, I think across 6 teams or so. Some people played with ASU's CTF team, or the security club at ASU, the Pwn Devils, and they play as Team Shellfish on the world stage. And some of the students in this course joined them. That was awesome to see. Other students formed their own teams and solved stuff. This is incredible. I think there was among the non-shellfish people, there were a union of 6 solutions in F-word CTF, which is super cool. Reading your write-ups was very awesome. Someone on Zoom asking if they can join in with one of the students. Make a post on Canvas and look for a team. So all of these people that submitted write-ups got 1 percentage point extra. So that is equivalent in weight to something like, by the end of the course, probably 7 or 8 baby suid. No, probably close to 15 or 20 baby suid instances. But they got that extra to their final score, 1%. We haven't calculated that in yet to these scores here, but we will. All right. Next, let's go on to some questions about baby suid. No. So for the next upcoming events, there are 3 CTFs next weekend. I'm not sure which one of these will have the more introductory questions or problems that you can work on. From the look of how many teams plan to participate, Alice CTF is going to be by far the most popular. So if you're looking for a CTF to do next weekend for extra credit, hop in to Alice CTF. Cool. Now, question about shell coding. All right. I have this shell coding module video where I talked about common challenges that you'll run into in this assignment. I'm going to reiterate the video, but I'm going to specifically answer a question that someone had. Well, I already answered over email, but I want to also get that to the whole course, that answer. All right. So I talked about multiple ways to achieve the same thing using shellcode, or using different instructions, right, or different combinations of instructions. And specifically, one student had a question, okay, but if I do move RAX 10, and you can see in the binary, the hexadecimal representation of the binary representation of this assembly, when you assemble this, it looks like this. There's a 4/8 byte, a C7 byte, a C0 byte, a 0/8 byte, and a bunch of null bytes. If you're using something like gets to read an input, and you can't have a new line, then this might be problematic, or this will be problematic. And so you need to avoid having a new line in your shellcode. Well, you can say the same thing as move the value 10 into RAX. You can do the same thing by moving the value 9 into RAX and incrementing RAX, right? So then you end up with this situation, right? So instead of a 0A byte, you have a 0.9 byte, because you're only moving 9. There's no more 10 in your code, and so you no longer have a new line. The student also had a question, why does this end up longer than this? Well, it ends up longer because this is 2 instructions. This is 1 instruction, right? So this is just move encodes into a very long instruction because it is moving a large immediate value, and this is that large immediate value, right? In little endian 0A 00 00 00. Over here is that move, and then afterwards there's another instruction that is inc RAX. Cool. More questions. More questions on shell coding? No question on shell coding. Connor, have you rebooted? Okay, perfect. So let me go back to pwn.college and spin it up. SSH in. Actually, while we were rebooting, what we should have done is increase the size of that instance. Oh, I see. Cool. They're still pretty slammed, huh? Okay. No, it launched. My home directory is a disaster. Oh, fuck. Thank you. All right, my home directory is a disaster. I'm going to... This is from running that crazy script. Half of this is owned by root. Okay. Half of this is owned by root. Amazing. Okay. Fine. We'll deal with that later. Oh, I'm in practice mode. Good. I can do it here. Awesome. Okay. Let me relog in so that it's not so weird. Oh, I just realized, Connor, probably the reason everything is so slow for me is whatever ended up getting installed into my shell when I was running every single binary in a loop. Okay. Anyways, we're back. So we have baby shell level 1, and there is no source code. Oh, and /challenges. Okay, and /challenges, baby shell, we have the source code of the different challenges that you have. So here is level 1 testing 1 versus level 1 teaching 1. I think for level 1 there's not much difference, and it's super simple. It welcomes you. It closes all other file descriptors than standard out and standard error, just so you don't do any crazy shenanigans. Zeroes out the environment and arguments so that you don't inject data that way. And the only way you can inject data is by sending it shellcode right here, where it'll let you read for level 1 OX 4000 bytes of shellcode. Let you write that in. Then it'll just execute it. It jumps to a function pointer pointing at your shellcode and executes it. That's it. For level 1, the difference between level 1 teaching 1 and level 1 testing 1 is teaching 1 will disassemble your shellcode and print a bunch of other helpful stuff, but mostly disassembling your shellcode. That right here. For level 1, the shellcode you develop for the teaching challenge will likely work on the testing challenge. Some of the later levels are not so easy or not so nice, but generally there's not like a lot of hidden data for shell coding that exists in that you wouldn't know ahead of time. in the teaching assignments, right? So realistically, whenever you get a solution for the teaching, you will likely be in a very good shape for the testing. Point is, though, the takeaway, there is the source code for the different levels in /challenges. We'll update the description when you like click in CTF and our CTFD instance here. Connor, can we put a description here? Check out the source code and /challenges. Awesome, awesome. Okay, can you push a couple extra levels and we'll get started on the, we'll do an hour and a half of collaboration. Mm-hmm. Awesome. I guess the earlier ones are the same. Is the CTF instance much bigger? I see. Well, let's start the collaboration and go with that. All right. A couple of questions to catch up on. A question about redirects on the open web. So if off topic, of course, but let's look at it. If a website that you don't want redirects to you, what can you do about it? This is a legal area. The likely answer, depending on what top level domain that website is coming from, you can probably do relatively little. But yeah, it's more of a human problem than a technical problem. All right, problem number one. It wants shellcode from std in, but my shellcode raw isn't std out friendly. So let me show you how this can work. All right, here we are in Baby Suite, and in this container, or in Baby Shell, in this container, GCC will work again, so we can reasonably do stuff. Let's write some shellcode, just very easy, easy shellcode. Let's bring in our standard preamble. All right. Let's rewrite the shellcode that just does an exit. So this will exit with a 42 gc static dash no std lib dash o shellcode elf shellcode.s. Sorry about that. Okay, and now we just run our shellcode elf, and we see that it exited with 42. We can strace our shellcode elf, and we see that it exited with 42. All right, then we can obj copy, dump the section out. Here's our shellcode raw. So the question was, if I cat this shellcode raw, it looks like shit, right? It just has a bunch of H's. So an interesting thing you'll find when you're looking at the essentially ASCII representation of your shellcode for AMD64, you'll see a lot of H's. H is an instruction preamble that tells the processor that this is 64-bit. This is a 64-bit instruction, which is pretty interesting. And one thing that you might have to soon think about is, what if your shellcode can't have an H in it? All right. So, Connor, someone on Zoom is saying that the challenge directory is only in the testing challenges, not the teaching challenges. Oh, okay. Yours might not have generated. We're still working on generating all of the challenges. Where's my mouse? My mouse is dead. Nope. Oh, my mouse ran out of batteries. Huh. All right, let's put my mouse on the charger. We're back. All right. Cool. What do you do if you can't copy paste your shellcode, right? Of course, this program, it reads things from standard in, so I can type it in here, but I can't copy paste this guy. If I copy, I mean, this could potentially work, but most likely it won't. Yeah, so it didn't work. No problem. Linux supports redirection of standard input. You can do it in two ways. The more common, but will potentially piss people off, if you just cat this, just like you do. But if you, excuse me, put the pipe, you can redirect into the into a different program, and when that program reads from standard input, it will actually be reading from the contents that you are piping into it. That's the verb. And there you go. It executes the shellcode, and you can see it exits 42. If we strace it, oh yeah. So if we strace it, it does all this closing of file descriptors, and then it does our exit 42. Very cool. So that's how you get shellcode into this program. This is what's called an unnecessary use of cat, and some people that are purists get upset at this. You can technically also redirect shellcode, redirect input like this. So this says redirect input from this file. Boom, same thing. You can also redirect the output. What? Shouldn't matter. I have no idea why output wasn't redirected there. No idea why that doesn't work. Let me show you on LS. That obviously works, right? Redirect the output of LS into a file. Again, this is kind of some of the stuff that the course assumes you come in knowing, but you know, if there are gaps, you can fill them in. All right. Question: do we have to do both teaching and testing? Yes. Can you talk about position-independent shellcode? All right, I can talk about position-independent shellcode. Let me show you shellcode.s. All right. So let's say that I had position-dependent shellcode. I can, and in fact, the default way I teach you to compile, to assemble shellcode creates a position-dependent statically linked program, where if I run the shellcode elf, break and start, that's always going to be 4x 4010. If I run it, here we are. Let me show you the next. Let me show you the next instruction, and it moves 42 into RAX. You can make GDB less wrong. Set disassembly flavor in. Oh, hold on, let me just copy that out of my GDB init. There. What did I misspell? Disassembly. If you put this in your .gdb init in your home directory, GDB will be less wrong. But hopefully you installed one of the GDB fancy GDB things that I recommended, like pwn debug. All right, let's do this again. Break start. Display the next instruction, and then run. All right, here is 42 being moved into RAX. All right, and it's always at 401000, right? So we can take shellcode.s, and we can say, okay, at let's say we wanted an exec shellcode. That is exactly 59. How do we figure out what exactly is? Very easy. We go to Ryan A. Chapman. Just Google for Ryan A. Chapman, syscall, and there's your syscall table. Amazing. So then you search for execve, and it's 59. That's not very visible on there. Here we go, 59. Awesome. All right. So we're writing a shellcode here that will trigger syscall 59. Execve takes as an argument the string. Obviously, we can't just put it here to run, so we need to put it somewhere. Let's put bin.sh here. And I, of course, talk about all of this in depth in the lectures. And then here, let's say we, let's see if this will work. And then we move RSI 0, move RDX 0. Let's compile that. Okay, let's look at what it looks like. Okay, so this shellcode is reading from a direct address, this 40101F, into RSI. And actually, what we don't want it to read out of that, sorry. We want it to load that effective address. So we load the address of the string into RSI. So let's compile this. So same thing. Loads the address of this string that is in memory in the text section a little lower, right? What this looks like when we run is a direct memory read. And this works because this binary is in the right space in memory, right? So now let's extract the binary. Let me see if I, yeah. All right, so we extracted the binary. And you know, if you just run it, what's going on? Execve null 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 null. Oops. RDI. No one caught that? Come on. Okay. If we run it, gives us our shell. Great. If we opt copy it out and then we cat that into baby shell testing, we get a illegal instruction. Now this says core dumped. Connor, the core wasn't dumped. Can you make sure the core format is correct on the server? Anyways, let's we'll do something. So we can run it in GDB in the meantime. We can run with the input of shellcode raw. All right, so it crashed, right? And it crashed here. So why did it crash here? Let's this unenhanced GDB is annoying. Let's look at the registers. RSI 0, RDX is 0, so those are the second and third argument to execve. RAX is a negative number. That's the return code -14 from execve. Let's strace this so you can see exactly what happened. This is what happened. We passed in a position-dependent address of our shellcode, in our shellcode, that we got that was correct when we were looking at the shellcode in the context of a position-dependent statically compiled ELF, right? This and this synced up because the whole binary, when this runs, gets mapped here. That's bad news when the binary is not mapped there, as we can see here, or when the shellcode is not mapped there. Absolutely, man. Illegal instruction. It didn't even claim to generate a core dump now. All right. So, let me regather my train of thought. So, the position independence. That's bad news. Now we need to figure out how to make it position independent. And someone on the Twitch is a real deal Shellcode Pro because they know that AMD 64 added some amazing functionality, which is to offset in a memory load or a memory address load effective address the instruction pointer. If we do this, if we do RIP plus bin sh, and we compile this or assemble it, and we obj dump, we see something completely different now. Where there was a hard-coded address, there's now an instruction that instead says, instead of loading the address directly into RDI, just take the address, take the current instruction address or next instruction address, add 16 to it. So the next instruction address is here. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and here it is. 16 is right here, 2F. And that's it. It's that simple, right? So now with a change of 4 bytes, this shellcode is 4 bytes in the assembly. This shellcode is position independent. We can opt copy it out, and we can run it. Ah, fudge. Yeah. Okay, so we ran it. You see it exact bin sh. All right, now here's your next problem. And I mentioned this in my office hours stream. We're catting something. We're redirecting input into this guy. And then when bin sh runs, it reads in a command from standard input. Standard input no longer has anything inside it. So it exits. So we can solve it in one of two ways. We can put cat here. So what this does is it'll first redirect the output of cat shellcode raw, and then redirect the output of just cat, which reads from input and then writes out the output. So here it is. Now we have a shell. Why? Oh, because bin sh, you don't want bin sh. Bin sh will drop privileges. Let's actually go into this real quick. Bin sh has been used in so many of these sort of attacks where you have a set UID binary and then you call bin sh, that bin sh checks if it is being run from an SUID parent process. So it checks if its effective address is different than its real address, and if that effective UID, then it's real UID. If the effective UID is 0, the real UID is non-zero, it'll actually drop privileges by default. You can add an argument. So instead of running bin sh, we can run bin sh -p, but then we would have to work with this the second argument and so forth. It's a giant pain in the butt. My advice, create, instead of running bin sh, run /home CSE 466 /cat flag. Let's get our create a cat flag. Send file 1 open /flag 001,000. Nice and simple. Cat flag.c. Okay, and then let's just run. Let's GCC the shellcode, obj copy the shellcode, and we shouldn't need this anymore. So now we just figure out why it's no longer working. Let's easier debug here. Illegal instruction. What did we do? Oh, that's afterwards also. It's much easier if your shellcode actually cleanly exits, so you don't have to debug what went wrong. You can tell that something went wrong when it crashed instead of wondering. Okay, this seems good. As Trey said, it tries to run cat flag, and there's no such thing as cat flag. Oh, it's home CTF. My apologies. Okay, GCC, obj copy. We run. Okay, perfect. So now, as you will see, we run our shellcode. It will run our where did it start? Okay, here. It runs cat flag, then cat flag will try to open the flag, but of course it doesn't have permissions. So a good way of debugging this to make sure that you have the right permissions and so forth, or you have the shellcode correct, it's actually trying to open the flag correct. Launch this thing in practice mode. Did I do that? Yes. And now you can chmod the flag to be world readable, to make sure that your cat flag works, to make sure that your shellcode works. Then make sure that your full end-to-end attack works. Boom, it works. Our shellcode ran, opened the thing. It's now position independent. Of course, you can make a position dependent shellcode that will happily work at this address. You just need to compile your program in a way that or manually specify the memory read address. It's actually on x86. Position independent shellcode was harder on 32-bit x86. On 64-bit x86, position independent was hard on 32-bit. On 64-bit, position dependent shellcode is almost harder to write if you want a specific position, right? So just use this, it's called RIP relative addressing, and it's all good to go. So anyways, now we got this practice flag. This doesn't do us any good in terms of points on the scoreboard. If we go and launch up, which one is this? Testing 1. We launch this for real now. SSH in. The home directory is preserved. I can just literally hit up, enter. Hold on. Now it's ready. I've reconnected. What the fuck is going on? Okay, there we go. Why isn't my history preserved? Whatever. Cat shellcode raw baby shell, and boom. And this is the real flag. That's my flag. Don't use my flag. Get your own flag. But I'm going to submit my flag so you can see that it works. Boom. Okay. And now I have baby shell testing 1. Let's catch up on questions. Yes, SH drops privs, as someone in Zoom said. Someone asked, Can you just use a different shell? Do they all drop privileges? They do not all drop privileges. Different shells, like K shell, last I checked, didn't drop privileges. I don't think that K shell exists on here. No, but it might be worth installing, Connor. But you can also use the like. Okay, question: why was it harder to use -p in the assembly? Let me write a C program that runs sh-p, and you'll see. Here's what we have to do. We have to exec ve bin sh, and then, and I'm going to write something that doesn't look like C. We have to give it argv 0 and argv 1. So we have to give it argv 0, and we have to give it argv 1. This, roughly speaking, is what it looks like. Of course, this isn't valid C. So now we have to have a char star star argv, and we have to have a char. Let's do this char star star argv that has two things in it. One of which is bin sh, one of which is -p. Right, and again, we're still in C. If I got my syntax correct, let's see. Oops, I almost got it. I also have to null terminate this argument list. Now what? No, it didn't null terminate. Oh, yeah, that's because I had two. So I actually need three things in here. Run it. Boom. That works. All right, let me show you. Let me just. Yeah, so let me show you what this monstrosity looks like. This, with some setup, now we've turned a very simple thing into this insanity, right? Where we have to set up all of these structures in memory. In C, it's a pain in the butt, right? This took me a couple minutes. In assembly, it is going to be a bigger pain in the butt, right? So we have to have one string that is bin sh, one string that is -p, and we have to have our null I'm sure there's a better way to do it, but I keep forgetting how, what is the 8-byte constant is called. 1, 2, 3, 4. That's the 8-byte guy. And then we have to set up somewhere on the stack. So here we do bin sh. RSI needs to point to so let's do this. Load into rbx rip plus bin sh. This is argv0, the name of the program we're gonna be executing. We will push that onto the stack. Yes. Then we will move that. No, we have to do it backwards. We'll first. We don't need the null bytes. What am I doing? We'll first push null bytes. Then we will push this -p. Then we will push this bin sh, not move with load effective address. And then we'll move point RSI at the shell. And I think this might work, but we'll have to debug probably. Okay. Oops, dash o shellcode elf. Okay, shellcode elf. Holy crap. Who is impressed? I am so impressed with myself right now. One shot. Okay. Let's see. My thought. I'll catch up on that later. Okay. So, kill that. Okay. So now we have something that will run sh-p, but you can see how much longer that is. My old shellcode was beautiful. All of this was one line, right? So that's why I would recommend just having your own as like replacement that'll cat flag. All right, but now if we obj copy this, oops, why did my history not save? Something's wrong. Anyways, okay, if we obj copy this dump section into shellcode raw from shellcode elf, now we do shellcode raw baby shell, but of course we need to cat here. Boom! Running as root. Oh, that's interesting. So yeah, exactly. Never mind. Yeah, effective UID 0. All right, that is how you use shellcode that will work with having sh run. Okay. Let's catch up on some questions and then we'll move on. It's exactly time for the collaborative. Connor, how is level 2 doing? Did we generate it yet? Okay, so we'll add. All right, what do we got? Okay, so I'm starting from. Oh, can you show the cat flag C program again? Here it is. Zoom FPS so low I didn't see him null that list. I'm sorry about that. The nice thing is the lecture's available on Twitch immediately, and then it'll be on YouTube very soon. Some people saying that ASU 330 didn't quite prepare people for this. Is 330 the computer organization course? Oh, it's the last course. I see. Yeah. How do I save my code in the server? All right. We have a question. When you log into the server, it drops you into /. This is the root directory, and you don't have write permissions to the root directory. If you just type cd and enter, it'll go back to your home directory, which is home CTF. Here you can do everything you want, and it will save it across all of your challenge instances. So you can actually use this as a workspace. We'll do our best not to accidentally delete anything. All right, this assignment looks like it's going to be rough. Well, I have faith in you. You can all do it. Are you going to pose the solution for level 1? No. In fact, the shellcode, if you go through the videos, the shellcoding videos, that shellcode will work for level 1. Not the bin.sh one, but the send file one. Or if you just replace bin.sh with your own file. All right. Cool. Let's catch up on Twitch, and then we'll go into the collaboration space. Is pwn.tools on the instances? Connor, is pwn.tools on the instances? Sorry, brain dump. Yeah, looks like pwn.tools on the instances. What is pwn.tools? I discussed it briefly in my videos. Basically, pwn.tools is a library, Python module for exploitation dev, and with an application to CTF specifically. go use it. It has shellcode generation capability. My advice to you is not to use that because that will not get you farther than, I don't know, some level in this homework, right? And then you'll have lost out on, you'll have to probably go back and learn everything and redo it manually to tackle and go further. Okay. Oh, someone on Twitch mentioned this command, cd dash. It'll switch to the last directory you were in. It's very useful. Someone's asking how many levels. I don't remember. I think there's going to be 13 levels. Okay, let's start collaborating. Okay, so how many people do we have on Zoom? We have 91 participants on Zoom. However, I think Discord is going to be a much better collaboration tool. Let's see how we're doing on Discord. Oh wow, the memes have been active. This is good. There's some good memes. I'll do more meme updates. Okay, that's great. Anyways, let's dive in. The Discord link for the world is on my Twitter, and the Discord link for the ASU students is on Canvas. Please choose the right one. That'll help you get to the right place. On Discord, I created a bunch of voice channels. Join the voice channels. You can stream your video and your screen if you want to collaborate. I see ASU students piling into one channel. You can do that, but it'll probably be nicer to have smaller, more dedicated groups for collaboration. So as a reminder, this collaboration hour, everything is a go in terms of collaborating on this shellcode assignment. Try to get through those first 2 levels, and then give yourself a good head start. I'm going to answer a couple more questions, and actually I'll probably stay on Twitch answering questions, but the stream's gonna get decisively less interesting. If it gets really less interesting, we might just end the stream. Okay, quick query, ASU people on Zoom. Do you want me to keep the Zoom open and create breakout rooms, or does everyone want to collaborate on Discord instead? Or rather, speak up if anyone wants to keep the Zoom open. No Zoom love? Am I still, do I have audio on? Connor, can you say something? Okay, I still have audio on. Good. So it sounds like no one. I will keep Zoom open anyways. What I will do is stop screen sharing on Zoom and give everyone rights to screen share. Please don't make me regret this. So now everyone can screen share if people want to collaborate on Zoom. Otherwise, homework module 2 is live. It is due 4 p.m. We'll launch all of the challenges over the evening. It is well, we launch at least 10 to get you started, at least 10 levels. It is due on Wednesday at 4 p.m. like the previous one. Good luck. And I'm still here. If you have questions, I'll be on Zoom audio, and I will also hop in to different Discord channels, and you can ping me. First 3 levels are launched. All right. Twitch question: should we copy the code to our local machines and work on it there? For this one, probably you can do fine. My advice is approach the teaching challenges first in practice mode. So you have sudo, you have everything you need. In sudo, you can install programs if you find something is missing, right? You can set up a development and exploitation environment in that home directory and be perfectly happy for this assignment. Long term, I would recommend having a local, dev and exploitation environment. Oh, you're right. Sorry. Connor mentioned you don't have network access, so it's actually hard to install things. You can SCP in, a local installation of stuff, but that's probably more of a pain than you want to deal with. So I think for this assignment, that environment is probably sufficient. And if you have requests on what to install, you can install it for next times. But in general, I would recommend setting something up offline and working on it there. Cool. All right. The My ASU link failed for Zoom. Oh, I didn't see this before. Okay. Text channels for each voice channel. Okay, I'm creating text channels for each voice channel on Discord. This is okay. Torch has a text channel. Rest has a text channel. Oh, I see. I can't move text channels into the Zoom channel. Okay. Swarm. Okay. All on the ASU side of things should be, text channels should be created. I am now doing the world side of things. Okay. As a reminder, if you're having Discord issues, we can keep using Zoom as well. There's some good memes. Good memes. Someone on Twitch uses Parrot OS. What is Parrot OS? We're gonna search the internet. Parrot Linux. All-in-one framework for cybersecurity software development and privacy defense. Based on Debian testing. Victim of the System D war. So paired is like Kali. Question for Twitch people: is paired like Kali in the sense that there's a lot of very broken software because of how it is installed and so forth, or is it like Debian with just some things added? Actually, I don't know if modern Kali has that problem. Give me advice for the buffer overflow challenge. We'll get to the buffer overflow challenge in 2 weeks. Be patient. Oh, those on the Zoom, if you're waiting for a breakout room, you don't have to wait for a breakout room. We can use the main room. Someone kernel panicked their system running our Docker container. Probably just, yeah, baby Suet Docker can do some weird stuff. All right, so a common question on Discord that I'm seeing as I bounce through here is how do you get started on the homework? Let's take a look, right? So here's, let's go start to finish pretending we are completely lost. I'm not very rare that I'm completely lost. It happens. Definitely happens. Okay. Oh, and Connor, we're putting up more and more challenges, right? There's someone solving these challenges live. Good. All right. So let's say I open this up, open up pwn.college, and I see level 1, teaching 1, hit play, same practice mode. All right. I can connect up. I will now SSH. One sec. Let me share screen on Zoom again. Okay. There we go. I'm sharing screen on Zoom. Connor, the server is getting slammed. Okay. So, I get dropped into this container. Note, Connor, can we make the home directory the default when we drop in, or is there a technical reason why? Yeah, let's add that to the to-dos we can work on it tonight. All right. Go into my home directory. Here's all my old stuff, but we're going to pretend this doesn't exist. All right. Cool. Okay. So we're here. Fresh. We go look in slash, and we see baby shell level 1, teaching 1, and in slash challenges, we see under baby shell the source code of the challenges. All right. So I look at teaching 1, and I see that this source code, what it does is it seems to memory map my shellcode. And I know this is repetition from before. I'm just trying to give a walkthrough. It makes sure that that memory map was successful and that it got mapped here. It reads in my shellcode, or it says that it will, and then it does, right? So reading from standard input into my shellcode mapped memory that is readable, writable, and executable, best case scenario, and it reads quite a lot of bytes, right? Like 16 kilobytes of stuff. And then it makes sure that it read something, and it jumps to my shellcode. Okay, so obviously my task is to create binary code that will jump, that the program will read in, execute, and the task for the challenge is to read /flag, right? And the /flag, of course, is only root readable, and this baby shell is setuid root, right? So I need to make baby shell read my flag by giving it shellcode. All right, so then I can start doing stuff like this. This segfaults high, in fact, doesn't disassemble to anything. Bad news. Okay. And the teaching version of Baby Shell, it'll disassemble your shellcode. This in homework 1, in level 1, I mean, you can disassemble your own shellcode, right? When you generate it and you look at it with object dump. In future levels, this is going to get harder and harder because the levels are going to mess with your shellcode. And so, disassembling your shellcode is going to be trickier to see what the state will be right when it executes, but the teaching challenge will do it for you. It'll do the mangling, and then it'll disassemble your shellcode. Cool. Connor, can you double check? I'm pretty sure that... Yep. Okay. One sec. All right, the ASU Discord link just got shared on Twitch. So I killed all of the Discord links. Okay. What message? Oh, well, it's irrelevant now. Let me create an updated link for the world, and if there are any ASU students that need that link, ping me. And probably what we'll do is after this call, we'll just wipe that Discord and resend out the link. All right, I guess we should have expected that to happen. Oh yeah, that's a good point. There was one person and 6 minutes ago that joined. Nah, cool. All right. Anyways, can you create a new link and then respond to my Twitter, my tweet with that for the world? All right. Anyways, let's go back to this fun. All right. So now I have this challenge of having to put in shellcode that will get me the flag. That is that can be done in a number of ways, but we're gonna write it from scratch because we are awesome. So then I watch my own lectures, and I see that we can write assembly. Actually, let me back up just a little bit. What if we get our old cat flag.c? Right, here's cat flag.c. And we just compile it, nice and easy. We're just compiling a C program. What happens when you compile a C program? What actually happens is first, GCC invokes the compiler. GCC is actually a big wrapper around a lot of different tools that are collectively called GCC. First, it invokes the compiler. The compiler will compile cat flag into cat flag.s, right? Cat flag.s. No, come on. Dash capital S, sorry. A lot of these tools will do more than they should. All right. So when you compile a program, the term compilation, it originally generally means generating assembly code. So you end up with this assembly code that is generated. There's no way to make this in proper syntax. It uses AT&T syntax, unfortunately, internally, but that's okay. But of course, we could rewrite it with Intel syntax, the proper syntax. So now we have this. Then it assembles it. So it assembles the shellcode to cat flag.o. And now we have an ELF file. And then it links cat flag.o into cat flag. This isn't going to work because LD takes some arguments that I don't remember off the top of my head, but we can simply replace that with GCC and it calls LD properly, right? So this is the multi-step process to create a binary file, right? In the same way, if I was lead enough, I could literally sit down with a hex editor and write my shellcode, right? Kind of we should add a hex edit to the things we want to install on this challenge box. But I've known people that could write a couple of things. You know, I have several assembly instructions memorized. For example, in hexadecimal, EBFE will do a tight infinite loop. It's very useful when you're trying to debug some shellcode. All right, but I'm not going to write this in C, so I'm going to write it in assembly. In assembly, as you saw in our cat flag assembly, there's a whole bunch of this sort of metadata that's generated, or not metadata that describes the file, describes what section, describes a lot of stuff, right? We don't need all of this stuff, but we need some minor amount of things so that the assembler can function, right? So now we go shellcode.s, and we do the same thing. We write the file that the compiler would generate, and the minimal that I've determined through like trial and error and Googling is this. We need a start symbol. That is where execution will begin when we assemble this, when we do the AS step, similar to what we did with cat flag. And that start, so we say there is a start symbol in this binary, and that start symbol points right here, and everything that's going to go after this is in an Intel assembly syntax. Technically speaking, if you're willing to write AT&T assembly, I wouldn't recommend it. You can remove this, but here it is. And here we can start writing our program, right? So actually, if you want, I have no idea if this will work, but if you want, we could try to take cat flag and actually move this stuff. So here's cat flag. I wonder if we can just move this. This is going off script. Might be a terrible idea. It's probably a terrible idea. Move this into our our minimum shellcode. So let's move it here. Here we do our preamble. Of course, in the normal, cat flag compilation process, the assembly specified a main instead of a dot start and so forth. But we don't. We are just going to put this directly in the entry point of the binary and hope it works. There's a couple things we don't need. One of that, specifically these directives are for control flow integrity. They are actually to prevent exploitation. They insert some additional stuff. Let's take this out. This LC0 is probably the cat flag path. Where is LC0? Here it is. Yep, so we're going to take that, put it here. And this is AT&T assembly syntax for instruction pointer plus LC0. So from this, you should hopefully understand why AT&T assembly is unusable. In Intel assembly, it's just RIP plus LC0, much easier. All right, this should be our cat flag exactly done, except for this return. There's nothing to return to. This will just crash. You might as well remove it because there's no function that set this up. There's no function that called us. Ret returns from a function call. I honestly don't know if this will work, but we're going to try. So in the same way, we can assemble shellcode.s into shellcode.o. Sorry, this no longer makes sense because we are not using Intel in there. Okay, we assemble it. It actually assembles. We'll link it into shellcode elf. Okay, yes, and now we are having trouble because there's an undefined reference to main. So let's instead say, okay, try this as main. I realize I misspelled global, so I wonder if I even need that line. All right, let's assemble it. It actually compiles. If we run shellcode-elf, actually since we're in practice mode, we can make the flag world readable so that we don't have to worry about the SUID and stuff. Let's run our shellcode elf. And it works. So what we just did, we took cat flag.c, this, we compiled it into assembly with -S. You can also, you don't have to run CC, you can do GCC -S. Okay, this just compiles it. And then there's also a GCC dash to just do the assembly without the linking. I forgot. Anyways, you can use AS. So anyways, we compiled it into assembly. So this is the assembly that is equivalent to our C code, that our C code compiled into. And then we extracted this into our minimal shellcode, and we wrote the shellcode with it, basically. And here's our shellcode, and our shellcode will do the same thing that our cat flag does. Of course, just to summarize, our shellcode looks like crap because it's an AT&T assembly. And afterwards, it'll crash. But actually, we had ret in here. If we put ret back in, it won't even crash. It'll return from main properly. Let's assemble that shellcode. We can just use GCC for all of this. Right, so we can actually GCC shellcode.elf -o shellcode.elf from shellcode.s directly, right? Like we do, like I talk about in the slides and previous lectures. Then, if we launch our shellcode elf, amazingly, it actually works, and that clean return makes it golden. All right, so now things are a little bit harder because we can't do our object copy trick because this isn't the only assembly in the binary, right? Because this is an actual normal binary, but this shows us the life cycle of everything. So now we have to convert shellcode.s into actual shellcode that will run if you just export the raw bytes and pipe it into a program. into your shellcode. So there's a couple of problems. One problem is this call send file. This is a library function in libc that we don't have access to when we are and actually this open. And we'll talk about all of that a little later about how library functions are resolved and so forth. But bottom line is your shellcode should really, for the purposes of this module, hold on, I think I just lost audio. Can somebody say something? Oh yeah, I lost audio. Great, 1 second, let me reconnect my headphones. The joys of Linux. All right, we should be back. Can someone say something on Zoom? Hold on, let me fix my audio and reshare. Connor, can you say something on Zoom? Connor's either dead or I don't have audio on Zoom anymore. Okay, people can hear Connor, but not. But yeah, of course, you can still hear me because my microphone isn't the freaking AirPods. All right, pretend that which is now true, I can no longer hear anybody. It's a Zoom issue. Interesting. 1 sec, let me restart sharing again. Connor, can you say something? Yep, can you say it again? Okay, perfect. Zoom just needed to be shaken up a bit. Okay, we're back. All right. Oh, wow, it got dark. I didn't realize. Let me turn on lights. And sorry about that noise. Plugging in my fancy studio rigged up light. Okay, cool. So the bottom line is your shellcode can't call into library functions. There are a lot of technical reasons that we'll get to later. Bottom line, don't do it. So what we need to do is make system calls that'll call open and send file instead of library functions. And then we can change this to .start. And once we have that, we can compile this as our what's it called? Our shellcode, right? In how I talked about in the lecture. Let's start converting into shellcode. One, all of this push RBP, move RSP RBP. This is, I'll talk about what this is more in the reverse engineering lectures. This is basically a function setup. It's called the function prologue, and down here is the function epilogue. We don't need this shit. We don't need this stuff in shellcode, right? So we can remove this. We can remove this. Moving 0 into EAX before returning. This does the return 0. EAX, and of course that extends into REX, is where the return value lives of a function. We don't need this either. We're not worried about returning. Now, and again, hopefully this will be the only time in class where you'll see me work with AT&T syntax, but we're just going to stick with it. So we need to change this open and this send file to system calls. So what do we do? Well, we're going to, first, there'll be a syscall instead of this open. And 2, we need to figure out move L some number, and this is again AT&T assembly. Here, this EAX. We need to figure out the syscall number of open and the syscall number of send file. How do we do it? Someone on Zoom, say it. Connor, how do we find syscall numbers? Ryan A. Chapman. Okay. We need two numbers. We need open. Open is syscall 2. Nice and easy. We need send file. Send file, send file, send file, send file, send file. I'm going to search for that because I already missed it. Send file is 40. Okay. So we're going to do 2 into REX here, or EAX, and then a 0 extent. Sorry. Back to here. And 40 here. Okay. So we started with catflag.c. We went to catflag.s by assembling it. We extracted that file, the assembly here, put it in shellcode.s. We had and that had these open calls. I commented those out, and I changed them to system calls. And now we're gonna compile it with our no stdlib, because we're no longer using libraries, because we can't use libraries when it's shellcode, when we actually inject it, with a static elf, just so it's small. In this case, actually, a static elf is smaller. It's easier to work with. Okay, and then now we can opt dump. See what happened in the end. -d shellcode -elf. Here's our shellcode. Here is this is that string. Here's a syscall. Here is syscall. Pretty amazing, right at start. So let's strace execution of it. And something got screwed up. So we opened the flag properly, and when we were sending the file, we put a 0 instead of a 1000 somehow. So something got lost. ECX. So probably ECX isn't actually, yes. So this is a difference between calling a user space function and calling a syscall, possibly. I'm too tired to say it off the top of my head with authority, but the fourth argument in a syscall is R10. I'm guessing the fourth argument in a normal function is RCX. Oh, that might be true. All right. So let's move into R10, this 1000, and this now has been moved Q. Assembly syntax is not very nice. Okay. Now we compile it again. Now we strace it. And now it works. We fixed it up. Boom. So again, we started with C. We compiled that C into assembly. That's what happens to any C program you compile. It'll become assembly eventually. Then we assemble that into, or then we pull out that assembly, translate it to fix some stuff up so that it's valid shellcode, and then we put it in this file. Now we can extract it with obj copy, and now we can cat that to baby shell, and it's segfaulted. Oops, what is all this? Here's shellcode elf. Here's shellcode raw. Yeah, that's correct. And this is fine. What is all of this? Where did this come from? Okay. Okay, I have no idea what happened. Oh, did I cat shellcode elf? No. Yes, I did. Sorry, classic mistake. I sent my entire elf file as my shellcode. That is not my shellcode. All right, my shellcode is actually the extracted version. Boom, and you can see it ran. Let me show you. But of course, we have flag in practice mode. We chmonitor. Let's make sure that this will work in real mode. It works even if the flag is 0600. Let me log out, rerun, go back here, go here, run, start it in real mode. Okay, I think that's ready. SSH in. Let's make sure I know I was, yep, awesome. No more pseudo access. Then I just do the exact same thing and I have the real flag. Again, this is my flag. Please don't submit my flag. You will end up getting knocked for cheating. All right, correct. Cool. Did this help? Awesome. People piling in. That it helps. Okay. So basically, what you are doing is kindly, out of the goodness of your heart, extending the functionality of a vulnerable program to implement a feature that unfortunately the original authors neglected to add, which is a feature you want, which is reading the flag. Or if you are less benign, infecting the, victim's computer, or if you are, the possibilities are endless. When I talk about this in interviews with non-technical people, I say it like this: you're taking a program that just knows how to dance. Sorry, I fucked that up. You're taking a program that just knows how to walk, and you teach it to dance. All right, that's what this sort of exploitation is about. You're dancing with the program. Baby Shell, all it does is read in content. That's it. That's its functionality. It reads in content, but because it also jumps to that content, you can make it do anything, and you make it do anything by initially thinking, what do I want to achieve? You can write that in C, assemble it, and go step by step through that, or eventually you can just start directly from the assembly. Global start underscore start, that's where an execution will begin. Intel syntax no prefix. And now the world is your oyster. What do you want to do? You can do anything. Typically, if you're just doing this live, you just do 60 into RAX, 42 into RDI. Oops. See, I'm infected with AT&T syntax now. And syscall, and you exit. Exit, stage left. Dash static, dash null stdlib, dash o, shellcode 2elf, shellcode 2.s. And we exited 42. Cool. So you can start from C and then move into assembly, but eventually I'd encourage you to think in assembly. In some sense, we leave the C behind when the program is compiled. What is left is not C. But if it helps to start with C, then you can do that. Also, that'll get you through level 1 for sure. Then things start getting a little harder. Actually, this shellcode will probably also work for level 2 because it's position independent. But things will, the first couple of levels are actually very, very similar, right? They're just meant to explore slight subtleties of your shellcode if you happen to use them. But starting from like level 5, you're going to start having a worse time. Let's take a quick look at level 5. Just look at the source code directly. Level 5. Interestingly enough, if you want to figure out what the shellcode is doing, the source code of the testing challenges is much easier to read than of the teaching challenges, because the teaching challenges have a bunch of like debug and so forth output that's a little hard to get through. So here's that memory mapping. Here is it makes sure to map it at this address. Reads in your shellcode, OX1000 of it, and then it looks like it filters something. And I can recognize that this right here is a filter of the assembled the binary representation of the syscall instruction. So you can no longer do syscall. Now, how are you going to read from memory? Or sorry, how are you going to read the flag? Right, so it starts getting harder and harder. Cool. All right, I'm going to check in on Discord. Dang, we had a massive downfall of the sandwich channel on Discord. What happened here? Ah, crap. Connor. We may have forgotten to take out level 3. It's the buffer overflow. That's 2 weeks away. Can you take level 3 down real quick? All right. Students, I'm actually going to add, well, hopefully they're all watching the Twitch stream still. We're going to remove level 3 real quick. Because we meant to update it with a different level. So for now, there won't be a level 3. Sorry about that. If you can solve it, then you're kind of ahead of the curve. We'll cover the level 3 material in 2 weeks with the memory corruption module, or 3 weeks. 3 weeks. Yeah, sorry about that. Focus on the shell coding. Nice. I see someone starting to execute shellcode on Discord. Some good memes. Yeah, so we'll replace level 3 with... we'll just replace it with a freebie. An echo. The flag is this channel challenge. And then we'll... So then there might be a total of like 14 levels instead of 13. Our bad. Okay. Cool. Okay, we're nearing the end of the stream. Any final questions? No, level 4 and 5. Connor, did we forget? Do we still have buffer overflows in level 4 and 5? We don't. No, we don't. Yeah. I think level 3 was the only one. Let me SSH in and look at the source code. Yeah. So we had that one buffer overflow. Level 3 testing 1. My bad. Yeah, that's a let's screw up. Now we know. We will fix it. Okay, just to make sure all the rest have 1, 2, 4, and 5. Perfect. Yeah. Awesome. Okay. So whoever is saying I spent 5 hours working on level 3 on the old site, that will be useful in Fratiger on Twitch. That'll be useful in the memory corruption module. We'll go straight into that. Any other questions before we change? Okay. Someone on Zoom submitted my key for level 1. That's very bad news. Connor, can you unsolve level 1 for this person? Okay. Yeah, please don't submit my my flags off stream. We have 7 more minutes for questions, and then we are out of here. All right. I think we are pretty good. Any questions on life? Connor, do you have any questions? How did I get started on all of this? That is a question. I got started on hacking. So I got started in computer science when I was 5 or 6 years old, when my grandma got me a book called Professor Fortran's Encyclopedia. It's in my office at the university. And it was a children's book. And whatever, first grade me read it cover to cover like a million times, obsessed with computing. And then I was hooked on like the concept of computing ever since, right? There's an awesome book for kids. Then I got into hacking in high school in the typical way you do. You start messing around with Linux, and then you have a Linux server, and then you give your friends access to that Linux server, and they give you access to their Linux server, and then one day you log into your server and they rooted it. And you're like, okay, what the hell happened, and how can I get them back for this? And then this leads to continuation of constant building up of knowledge. The other reason that I'm doing this on this level is that I went to an undergrad institution, Rensselaer Polytechnic Institute, that was extremely serious about this type of computer science education. In fact, this class, at least through, I don't know, week module 4 or 5, was our computer organization class. Not this exact class, but these concepts were forced on us in computer organization rather than in our senior year. And RPI actually has one of the top undergraduate hacking teams now in the world, which is super cool to see. They competed at the World Championship of hacking, DEF CON CTF. So yeah, it was a combination of my friend hacking me and good undergraduate place. Question on why does ASU take so long to get us to the good stuff? It's tricky to get this stuff. You have to be willing to kind of if you introduce this early, a lot of people will fail that course, right? And you can have a viewpoint of, okay, a lot of people will fail, but that's just life. They'll have to drop out of the CS major and so forth. And that was, when I went to college, was the viewpoint that RPI had, right? it's not quite the viewpoint that we have. We're trying to be a little bit more inclusive, but there are balances, sacrifices, and compromises that have to be made. So instead, we tried this ramp up approach. But maybe there's room for like an alternate track where people that understand what's involved will try to push through much harder classes or something along those lines. Question on the Twitch: how good is ASU's hacking team on the world scale? All right, so ASU has a cybersecurity club called the Pwn Devils. The Pwn Devils hack on the world stage as Team Shellfish. Let me show you the DEF CON CTF. So the DEF CON CTF is one of these sort of the world championship event in in computer hacking. If we go to DEF CON CTF 2020 final, so DEF CON CTF is run by me and my and colleagues and friends as the team, the Order of the Overflow. That's what this T-shirt is all about. Last month we ran the championship event of 2020, and a team won called AOE, A0E from China. Shellfish is right here, 7th best, at least in this championship, hacking team in the world. Right, so not all of Shellfish is ASU people, and so on. But ASU makes up a significant chunk of this team, alongside friends from UC Santa Barbara, and places around the world. So yeah, I guess 7th. An interesting testing ground is coming up, which is called Seesaw. So Seesaw undergraduate CTF, but rather than that, let's just go Seesaw CTF. So Seesaw is one of the biggest educational cybersecurity competitions around, and it is happening next weekend. This will be my officially sanctioned, possibly mandated CTF for extra credit for next weekend, and I know Shellfish is going to try to push hard on qualifying for Seesaw. So they've been talking a lot. There's a lot of confidence in the talking. So hopefully they will get there. It's very hard to qualify for the final event. Only very few teams do. On the Zoom, someone mentioned, don't forget about DevilSec. So ASU actually has 2 cybersecurity clubs. One is the Pwn Devils. That's what I've been talking about. And if you go to Pwn Devils, oh my God, what is this? All right, if you go to Pwn Devils, if you scroll down, there's the Discord. You can hop on and chat with some Shellfish folk, and then there's DevilSec, which is the other. It's a cybersecurity club at ASU. You could also say Pwn Devils is the other club. DevilSec is the other club, but they're two clubs. DevilSec focuses more, my kind of internal categorization of this. Pwn Devils is the club to go if you want to develop exploits, if you want to break crypto, if you want to find new vulnerabilities in software. DevilSec is the place to go if you want to understand the security of already created, already deployed systems, and find, for example, configuration flaws, and understand how to ensure that the configuration is correct. And that the software is updated and so forth. So the takeaway is ASU's cybersecurity course, cybersecurity scene is pretty strong. Definitely quite active. DevilSec competes in a different set of competitions called the CCDC, the Cyber Collegiate Defense Competition. I forget what it stands for. So yeah, then and that season starts very. Oh, this is 2019 stuff, but presumably similar dates for 2020 as well. Someone is talking shit about the Pwn Devil CSS. This is the brand new Pwn Devil site. Come on. Look at this. This site is beautiful. Also, look at this guy. Huh? It's a good photo. Okay. Anyways. Any thoughts on how Samurai did this year in the finals during DEF CON CTF? Yeah, Samurai did awesome. Let me bring up the scoreboard again. I think they were 5th. Sixth. So Samurai played as the Unicode character for Samurai. Why? Okay, yeah, it's just taking time. They got 6th, so they beat Shellfish, for example, by a reasonable margin as well. I was super impressed with Samurai's performance on a challenge that I wrote for DEF CON, which was a machine learning challenge, where you had to attack machine learning classifier and basically do an adversarial image generation attack in a black box manner at first. That is, you don't have access to the classifier, just to its output, and then a white box manner where you got access to the classifier on the second day. And they dominated that challenge. We had a mechanic in DEF CON where when kind of the top team scores 600 flags from a challenge, that challenge would be closed, as if they killed the challenge. And Samurai killed my challenge very, very effectively. So that was super awesome. Yeah. All right, let's see. What do we got? Oh, okay. We are actually 4 minutes over time. So thank you for joining the stream. Sorry about spending so much time trying to get flags on Babysuit, but hopefully I got the point across there. If you have any questions on Baby Shell, please reach out to us sooner rather than later. If you're reaching out over email, please email pwn.college@asu.edu, not me personally or Connor personally, because if you email one of us but not the other, there's a much higher chance that something will get dropped. So email the mailing list. Or if you're an ASU student, you can also post on the Discord. Otherwise, good luck. We'll launch the rest of the challenges today and early tomorrow. And again, they're due at 4 p.m. If you run into on Wednesday, and we'll next week talk about sandboxing and how to escape some sandboxes. Have a good one. Keep hacking.